All right, Nathaniel, hon, I am not going to be editing this, so you need to get off the phone. All right, hello students. We're in class right now and we're doing arithmetic sequences. Okie dokie. And so an arithmetic sequence is going to be the difference. And remember, difference is just subtracting. Right, so we're not doing anything outside of what we already know how to do. It's the difference between consecutive terms. And consecutive terms just means terms that go in order. Like the first term, then the second term, then the third term, then the fourth term. That's what consecutive means. This difference is called the common difference. And each term is found by adding the common difference to the previous term. So when you look at the sequence, 2, 5, 8, 11, what did we add to 2 to get to 5? 3. And what did we add to 5 to get to 8? And to 8 to get to 11? Correct. So every single time we were doing plus 3. In some sequences, it's really easy to tell by just looking at it. But, you know, when the difference is kind of large and sometimes you just want to make sure you did it correctly, there's a mathematical approach that I'm going to show you on how we do this, okay? So with that in mind, the first term is 2. The second term is 5. The third term is 8. The fourth term is 11. And we need to find the next 3 terms. That's the 5th one, the 6th one, and the 7th one. So how do we find the 5th one? Correct, we add 3. So 11 plus 3 is 14. 14 plus 3 is 17. And 17 plus 3 is 20. All right, so the sequence is this one. Okay, oops, I erased my numbers. That's the sequence, right? And this is just the order of the terms. Common difference, we're going to do the second term minus the first term. Are you underlining this? So which one is the second term? 5. And which one is the first term? 2. So there you go. See, the common difference is 3. But we already knew that, right? The difference between the numbers is a positive 3. We were adding 3. And it works out for all of them. Let's say if I start with 8, well, what's the previous number from 8? 5. So if I do 8 minus 5, I also get 3. And it works for all of them, right? All right, so D equals 3. We're going to go ahead and plot this. And our end values are going to go here. Our A sub n values are going to go up there. A with a little n. Okay. So it's going to be the first 1, 2, 3. Oops, sorry, there is no 8. Maybe I should have skipped some. Oh, what else? All right, the first term is 2. The second term is 5. The third term is 8. Fourth is 11. The fifth one is 17, but it kind of looks like it's going to be off grid, right? So, first thing you should notice is that this is pretty straight, right? Like a line straight. And then every time I plotted these points, what was the rise?
3.
Positive 3, and the run was
1.
So the slope, if it were a line, the slope would be 3 over 1, which is just 3. Yes. This is basically going to be a y equals mx plus b deal, okay? And I'll start showing some difference. So the common difference is d equals 3. And what are the next 3 terms? We said it was 14, 17, and 20. All right, how do we check if something is a line? We check to see if it has a slope, a constant slope. All right, so from here, from this point to the second point, what's the rise? Let's try counting again. 4. And what's the run? 1. All right, so the slope here is 4 over 1, which is just 4, and we can double check. From the second point to this one right here, you see that 1, 2, 3, 4. The rise is still 4, and the run is still 1. So it is a constant slope. All right. So we're going to use what we know to determine whether these graphs are arithmetic or basically a linear pattern. All right, be ready. You're going to learn something new here. All right, we're going to be working with this left graph right here. Which numbers are the sequence? And we need to read them from the left to the right. So the first point is this one, right? So which one is the sequence? What's the first term? The first term is 2. So the first number in the sequence is 2. The second number in the sequence is 4. Third term is 7. And the fourth one is 11. All right, can you do the same for this other diagram here? On your own, without saying it out loud, just write down the sequence numbers. Just do the same thing that we did. All right, so you should have written 15, then 12, then 9, and then 6. Yes? Yes, Ms. Medina? Beautiful, beautiful. Okay, now, but this is a sequence. We have many types of sequence. The question is this an arithmetic sequence? And we need to make sure that we have just like for a line, we have a constant slope. For a sequence, we're looking for a constant difference. So let's check the difference between the numbers. And remember, the difference is always the second number minus the previous number. Third minus the previous, fourth minus the previous number. So the first one that we're going to calculate is 4 minus 2. Please make sure you're writing. 4 minus 2 is 2. Next one is 7 minus 4, which is 3. And the other one is 11 minus 7. 4. So was the difference constant? Is it the same? No. So this is not arithmetic. Nick, are you okay? Do you need to change seats? Because the common difference is not constant. And yes, it is a sentence, so common. So if I ask you, is this sequence arithmetic? And if you don't get a constant difference, you're going to say, no, it is not arithmetic because the difference is not constant. Understood? All right, so now can you please check if this sequence has a common difference using the same technique that we did here? So you're going to be calculating, I think, 3 differences here. What's the first calculation that you're going to be doing?
12 minus 15.
You need to make sure you're writing it down. Oh, and you guys know I'm going to be checking this at the end of the period along with my ticket out the door. So please make sure that you are keeping up with the notes. Thank you, sir. All right, so, you got to do the calculations yourselves and you got to give me answers. Let's go. That's why I said take out your calculators. All right, so you did 12 minus 15 is how much?
Negative 3.
-3, and then 9 minus 12.
Negative 3.
And the order matters, right? Because if you put them in the other order, you're going to mess up the sign. And 6 minus 9. So is this arithmetic? So yes, it apostrophe S, arithmetic. The difference is constant. Alrighty. Now, notice something right here. Would you say that this is kind of like a positive slope because it's rising? So look at the value of the differences. All of them are positive. So when you have positive differences, it's going to be rising. And over here, we have negative differences, so the sequence is decreasing. You see that? Negative slopes, negative differences. Okay, all of that is directly related. All right. Now, there's a lot to be said here. I've kind of already mentioned that. You can have fun with your vocabulary. A sub n is the term that we're interested in. A sub n minus 1 is the previous term. So what do you mean, Ms. Medina? Let's say we're interested in the second term. Which one is the previous term? Which term came before the second term? Which is? The first term. All right, let's say we want to calculate the fifth term. What's the term before the fifth term? The fourth term. That's all a sub n minus 1 means, is the term that comes before the one that you're interested in. So let's say we're interested in the 10th term. Which one would be the previous term? Which one would be the previous term? If you said it right before, you can say it again. I just want to make sure that the 9th one, a sub 9. All right, can everybody repeat after me? A sub 10, a sub 9. And that's just how you read them, okay? So just to make sure we got this, if I'm looking for the 20th term, what's my previous term?
A sub 19.
Did you say 87?
I said A sub 19.
Oh, got you. A sub 19. Correct. All right, so that's all a sub n minus 1 means, the one that comes before the one you're looking for. Okay, so if you can please remember that, then it won't look that scary. It only appears in recursive formulas, correct? A sub 1 will be the first term, because why? Because that's a 1. 1 means it's the first term. And D is our common difference. Now here's what you need to know. When we're writing recursive, the only thing you're going to put a value in is D. That's it. So here are some examples of what it's going to look like. So that you don't think, because in the beginning it does look weird. So the first example, it might look like this. A sub n equals a sub n minus 1 plus 3. There you go. There's an example of a recursive formula. All we did was substitute in a common difference of 3. You see? Let's say our common difference is 10. What does the recursive formula look like? A sub n equals sub n minus 1 plus 10. You see? That's how you substitute into this formula. There's nothing scary. The only thing that you're putting a value in for is this. And I tried to tell you that through my little notes here. Does it convey that message? Yes or no? Okay. You want another example? Well, let's do one with a negative sign. A sub n equals a sub n minus 1. Let's say the common difference is negative. Negative 12. There you go. Minus 12. Okay? All right, so explicit formulas. Let's do pink. In explicit formula, you're going to substitute in two things. You're going to have to plug in the a sub 1, which is the first term, and the d, which is the common difference. So let's talk about this right here. Make sure you write it down. Another way, this is n minus 1 times d. Clear? So now we're going to distribute the D. When I multiply D times N, I'm going to get dN. And when I multiply D times -1, I'm going to get minus D. I'm going to do this with some numbers now. Let's say we have N minus 1 times 3. Okay. Jaden. Tally. All right, and now I'm going to distribute the 3. Are you drawing the arrow? Jaden, are you drawing the arrow? Okay. What is 3 times N? 3N. And what is 3 times -1? -3. That's this part right here. That's what it is. You're just going to be distributing the D. Okay? Whatever value you put in there, you're going to multiply it in. You want to practice another one where you're distributing?
No.
Yes?
No.
Okay, let's practice one with a negative number. Let's say that the common difference is -5. So when we plug it in, it's going to look like that, right? So now distribute. All right, I'm going to put a stop on the video. I'm going to let you distribute and we'll be right back. All right, so what is -5 times N? And what is -5 times -1? There you go. Any questions? Do y'all see the magic? All right, so you should have no fear. When we're doing explicit formulas, the only thing you're going to plug in is a value for A1 and a value for D. So let's look at what it's going to look like. Because in the beginning, it all looks weird. Let's do an example. Let's say A sub n equals 3 plus n minus 1 times 5. See? You see how the only thing we plugged in was the first term and the common difference? Right? Obviously, later we have to simplify, but I'll show you that in a bit. Let's do one with A sub n equals 10 plus n minus 1 times -2. Any questions on how to substitute? We're good? Excellent. All right, now time to do examples. And basically, what's today's goal? Right here. I can write, let's go, a recursive formula. I can write an explicit formula. And this is for arithmetic sequences, okay? I can solve using both formulas. Okay. So if somebody tells you, write the recursive formula for this arithmetic sequence, boom, that's today's lesson. If I say write the explicit formula for this arithmetic sequence, boom, that's today's lesson. Clear? Evaluate this formula. That's today's lesson. All right, and the standard is FB.2. So our next quiz is going to be labeled FB.2. And it'll be on this for arithmetic and on this for geometric. And yes, before we go on Thanksgiving break. All right, so this is our sequence right here. Yes? What did you say? Why do you have an ear pod in your ear? All right, here we go. Which sequence answer question? So how many, let's go simple. Is this sequence, this is a sequence. Remember, a sequence can be any pattern, but we want to know if this is explicitly arithmetic. How do we check that? Yes, calculate the common difference. Write it down because this is your notes. So if I say, hey, is this arithmetic? I don't want you to be like, IDK, I don't know how. Yes, you do. It's called calculating the common difference. All right, so here you go. 22 minus 17. And then 27 minus 22. And then 32 minus 27. All right, you're on your own. Use that calculator. Your own calculator. Don't be stealing calculators from somebody else. Finish calculating. All right, so what's the common difference on the first one? Positive 5? Yeah. And the next one? And the last one? Okay, so would you say this is arithmetic? Yes. What is the common difference? D equals 5. Yes to arithmetic. There, you just answered 2 questions on the test. All right, how many terms were given in the sequence? 4 terms, right? All right, this is the first term. A sub 2 is the second term, A sub 3, and this one is the fourth one, right? Y'all see I put a little number? A sub 1, A sub 2, A sub 3, A sub 4. That means that's the term number. Which formula are we going to use to calculate A sub 7? Now, well, we're either going to use the explicit or recursive. And let me explain this to you. This is A sub 7. You see how close A sub 7 is to A sub 4? Right? Because then there's the fifth term, there's the sixth term, and then there's the, right? So we want to know what that one is. You see how close they are? When they're close like that, recursive is the way to go. I'm serious. Recursive is the way to go because I think all we're going to do is either add a number or subtract a number once, twice, 3 times, okay? All right, so the recursive formula, looking at the notes. Y'all ready? You should have it right next to you, right? I can't move the camera, so what is the recursive formula for arithmetic? How do we read that? A sub n equals A sub n minus 1 plus d. And the only thing that's going to be substituted in here is the 5, the d. All right, so the formula is going to look like this. The term that we want is going to be determined by the previous term plus 5. That's what this means. To calculate the term that you want, you're going to take the previous term, the immediately previous term, and you're going to add 5. So to get to 7th, we actually have to get the 5th one and the 6th one. Okay, recursively means that you got to do the process over and over again. So how do we get the 5th one? We need to add 5. So what's 32 plus 5? What's 37 plus 5?
42.
And what's 42 plus 5? 47. There you go. A sub 7 equals 47. And I'll try to write this down for you. What we did was, to find the 5th one, we did 32 plus 5. To find the 6th one, we did 37 plus 5. And to find the 7th one, we did 42 plus 5. All right, so writing it down can get tedious, like a lot of little detail, but actually doing it by hand is simple, right? Just adding 5 3 times. Recursive. Recursive is, when the numbers are close, the terms are close. The problem is when you want to calculate the 33rd term. Are we clear? That means 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and then 33. I'm not adding 5 that many times. Are we clear? That's why when the terms are far apart, we want to use the explicit formula. All right, so for far apart terms. And the recursive one is for closed terms. From the formula sheet, what's the explicit formula for arithmetic? A sub n equals A sub 1
plus n minus 1 times d.
times d. Okay. And remember, when we're doing this, Jaden, Tally, no napping in class. Oops, I said your name. I'm going to have to delete it. All right, A sub 1 and d is what we're going to substitute in. Do we know the first term? Look at the sequence, guys, at the bottom. What's the first term?
17.
17. And what's the common difference? 5. We calculated the common difference right here. Right. So now I'm just going to put the numbers in there, clear? And then I'm going to do some cleaning up. Notice how I put my 5 in parentheses? It's a little bit easier to not make mistakes when you have a negative number, okay? All right. And so now I'm going to distribute my 5. Right? 5 times n, 5n. 5 times negative 1, negative 5. All right. We're good? All right. Are there any like terms that we can combine?
Yeah.
Which ones are like terms?
Positive 17 and negative 5.
Positive 17 and negative 5 are like terms. So how much is 17 plus a negative 5?
Positive 12.
You all concur? It's 12? Okay. So then, oops, the formula is 5n plus 12. And it only took us long because it's our first one. Clear? Don't be so positive now. All right, a sub 33 term. That means that n equals a sub 33 means that n equals 33. Okay, so that means that a sub 33, the 33rd term, is equal to 5 times n, which is 33, plus 12. All right, so now you get yourself a calculator. Five times 33 plus 12. 177. What do you mean 165? All right, 177. 33rd term. Anything you want to share, Nick? Anything you want to share on the calculation that we just did? Yes. Yes, make sure that in decimals you're checking this, okay, or in your handheld calculator, one of the two. All right, so let me recap. I showed you how to write a recursive formula and how to use it. I showed you how to write an explicit formula and how to use it. Yes? Lesson achieved. Look at that. Oh my gosh, let's do it again. What do you mean no? Don't be rude. All right, these are the terms that they give us. You're going to have to take initiative here if you want to make sure that you did get today's lesson, okay? All right, these are this is the sequence. So this is a sub 1, a sub 2, a sub 3, a sub 4. All right, is it arithmetic? All right, we got to check that common difference.
Yeah.
All right. 47 minus 54. right? Those of you with a calculator, start calculating. Those of you without a calculator, start using your fingers or Desmos. But our computers are supposed to be closed, so that's why we need a handheld when we don't have access to Desmos. All right, anybody know what's 47 minus 54? 77? Oh my gosh. Okay, good. Is this one also -7?
Yeah.
Okay, so if they're all -7, then yes, it's arithmetic, and our common difference is -7. All right, how many terms were we given?
4.
4 terms. Okay. And so which formula are we going to use to find a sub 8?
Recursive.
Recursive, right? Because we got to do 5, 6, 7, and 8. They're still pretty close to each other from our last term, right? We have the 4th term and we want the 8th term. Recursively is going to be the easier way. All right, the recursive formula, can you look at your formula sheet? Is a sub n equals a sub n minus 1 plus d. Yes or no? Don't be afraid of the formulas, okay? So all we're going to plug in is the d. But this is negative, so it's going to be -7 or plus a -7, however you want to do it, okay? Okay, so this means from the previous number, we got to subtract 7. All right, so what's our last number?
33.
All right, so what's 33 minus 7?
Oh, 20. Wait. Yeah.
All right, 26. That means the 5th term is 26. All right, what is 26 minus 7?
Oh.
Let's go calculators, loud.
19.
19. I'm so glad you're here to give me the right answer. 19. That means that the 6th term is 19, right? Because we've done this -7 twice. Then you're going to do 19 minus 7. How much is that? 12. That means the 7th one is 12. And 12 minus 7? 5. That means the 8th term is 5. A sub 8 equals 5. That's what recursively mean. And of course, it took us longer because we wrote down the steps. But normally, you just go to your calculator and you do 33 minus 7, 26 minus 7, 19 minus 7, 12 minus 7, boom, I have the 8th term. All right, so now, which formula are we going to use to find the 100th term? Like literally from 4, 8, 9, 10, 11, 12, 13, 14, 20, 30, 40, 50, 60, 70, all the way. I am not subtracting 7 that many times. Are we clear? No way. I am going to write an explicit formula and boom, calculate it directly. Because it takes a long time. And I could mess up. And if I mess up in the calculator, then I'm like, oh man, I got to start over again. Was that the 42nd time or the 43rd time? Oh, no. No. Which formula are we going to use? An explicit formula. All right, right, the formula, what was it? A sub n equals a sub 1, n minus 1 times d. And I just got the formula from the formula sheet, okay? It's going to be given to you. I don't need you to memorize them. I just need you to know how to use them. All right, we need a sub 1, and we need d. All right, looking at the sequence above, what's the first term?
54.
54, here we go. And what was the common difference that we calculated? All right, so I'm just going to substitute it in. A sub 1 is 54. All right, we're going to simplify this because I also have to teach you how to simplify it. All right. Can you please be caught up so that you can pay attention? Hey, Jaden. Jaden. Everybody knows that we're gonna have to finish this recording soon. Otherwise, it's gonna take me like 5 hours to upload it to YouTube. Okay. Distribute the -7 correctly. Remember to like the video and to subscribe. Are we clear? What's -7 times n? Okay, -7n. What's -7 times -1? +7. All right. Any like terms that we can combine?
Yeah. 54 plus 7.
Yeah, so 54 plus 7 is what?
Oh, 61.
61?
Yeah.
All right, 61 minus 7n. Right, you gotta bring this down, and don't forget the negative sign. If you get the negative sign, you're gonna get the wrong answer because could I have written that differently, Miss Medina? Yes, you could have written a sub n equals -7n plus 61. It's the same thing. Clear? But don't mess up the signs. Jaden. Stand up, stretch, and then sit back down, okay? You gotta get blood flowing, oxygen into your brain so you don't fall asleep. All right, this means that n equals 100. N equals 100. So a sub 100, right? You see the little n right there? Equals 61 minus 7 times, you see the big N? 100. I'm sorry, I kind of went slow because I'm explaining it, but this beats subtracting 7 100 times, okay? And actually, technically, it would only be 96 times, but, you know, that's being petty. After 94 times. Anybody, let's go. I know you all have a calculator. -639. I need various confirms. All right. Okay, excellent. -639. You've been validated, my student. All right, there you go. All right, once again, I'm going to repeat what I just did. I gave you a sequence. We verified that it was arithmetic. We wrote the recursive formula to find the 8th term. We wrote an explicit formula to find the 100th term. Yes? Okay. Now,